Sure. So it's for question 60. It was for the tickets thing. It says their expected payoff for Anna if she bought 2 tickets out of 5 is $24. Does that mean that they get $12 for each ticket they get? Or?
Oh, okay. So I'll talk about it. So it says, say the price is worth 60, and your probability of getting is 2/5. So it says simply 2/5 times 60. Does that make sense?
So does that mean that the prize is split? Or?
No. It is, so say that the price is worth 60 and I have half probability of getting it. Then the expected payoff is like half of 60. So it's like an on average kind of thing. So half of 60 is 30. Make sense? So like if my probability of winning is 2/5, the probability of getting a $60 prize is 2/5. Then my expected value out of that is just 2/5 times 60.
So if one person buys 0 tickets and one person buys 1 ticket, then only one person will get 60?
Exactly right. Yeah. So if the tickets don't cost anything, that would be like 0.60.
And they cost like $12, so it would be 48?
Yeah, exactly right. Exactly.
I thought it would be interesting to do that properly.
In class. Yeah, that would be ideal. Yeah, you can print it up. That would be fine. No.
Protect from catching illnesses. It's so funny. Sometimes I let it. Like I know back to like I did. Yeah, just talking
Okay, any questions? How's the homework? Is it okay?
Yeah.
Is it doable? I have some questions. Any questions about it? Yeah.
Can we email it to you, or do we have to print it out?
The thing is that email is just harder to deal with in terms of, it's actually easier in terms of us dealing with it in terms of if you print it out. So it's just a little easier. Because email gets lost a little more. But yeah.
Do we have to type out the questions, or just wait?
You don't have to type out questions.
Okay.
Yeah.
Can we just write out our answers, or not?
You can type. I think it's okay. Any questions? I had some questions on questions 5 and 6. Did you find those doable, or did you find them not?
The Hollywood one was not.
The Hollywood Death Spiral thing?
Yeah.
You want to talk about that a little bit? And also the one about the raffle tickets? Did you guys do that one?
Yeah.
Yeah? You got that okay? Well, let's just talk about that better. I have some questions about each of those.
Do we turn it into you, or?
You turn it in class.
Okay.
So we'll bring out, I'll have these little boxes and you can, we'll pass the boxes around.
Okay.
Yeah.
Okay. Well, our TA grade.
Your TA grades. Yeah.
Does it have to be text or can we handwrite?
You can do typing or handwriting. Yeah. Anyways. People are more and more comfortable with typing these days. I guess, I don't know. But I don't know, I like it handwritten. Okay, let's see. Let's do number 5. Let's talk about it quickly. Okay, so you and a friend each probably choose a whole everything 0 and 5. Okay, so again, what's the first step?
Players.
Players. Who are the players?
Me and my friend.
Me and my friends. So there's 2 players. What's the next step? Options, which are 0 through 5. So I'm going to write it like this. I'm going to say it's like this person chooses from 0, 1, 2, 3, 4, and 5. So this is a more complicated one than the class so far. So far we just did so-called 2 by 2 games. We'll do some other examples. So here person 1 is choosing between those options, right? And person 2 chooses also between 0 and 5. Okay. So now the third step is what? To pay off one of the numbers, right? So let's do some simple ones. What if they both choose 0? It says, if you both choose the same number, I'll give you both that number times 100. So if you both choose 0, what do the payoffs do? 0. 0, 0. Okay. How about here? If we both choose 1. 100, 100, right? If you both choose the same number, I'll give you both that number times 100. How about if you both choose 2? 2. Okay, so this is the interesting part. What if I choose 2 and you choose 1? Okay. If your number is exactly 1 less than your friend's, however, then you will get your friend's number times 100, plus a bonus 100, and your friend will get nothing.
300.
Okay, so if I choose 2, so we're doing this little thing here. If I choose 2 and you choose 1, then who gets the bonus?
Your
Your friend, or the person who chose 1, right? Does that make sense? Because your friend is exactly 1 less than mine. So my friend gets how much? He gets 300, right? Does that make sense? Okay. And what do I get? And I get nothing, yes. Does that make sense? People get this? Yeah? Okay. All right, so the rest of it is just doing something like that. Any questions about that?
The follow-up question, it relates to this in that when there's two competitors, they end up both being winners, but the one that gets up on top wins over you, or?
I'm looking for something more specific. If you look at the newspaper article, if you look at the, this is back when DVDs were a thing, I guess. So it has to do with the, should I spell it out for you, or do you want to look for it again? It's, I want something, there's something really specific in there, which maybe you can find. Yeah. There's a question over here? Yes.
For your friend chooses a number exactly 1 less than yours, it doesn't say to add a bonus to that one. Would you also be adding a bonus? Someone said the last sentence in the first part. Similarly, if your friend chooses a number exactly 1 less than yours, then your friend will get his number times 100.
Oh, you're right. Oh.
You assume you're adding the bonus.
Oh, I see. Plus the bonus. Yeah. I'll change it again. You're right. It's just a minute. Thanks. I'll change it. Thank you. Any questions about this? Okay. All right, let's do number 6. Okay, let's just talk about that. Okay, Anna and Bob are trying to win a prize. Let's do that. Okay, who are the players? What are their options?
0,
0, 1, 2. 0, 1, 2, 3. Bob. 0, 1, 2, 3. Okay. They're the only 2 people in the raffle. Each ticket has an equal chance of winning. So, for example, if Anne buys 2 tickets and Bob buys 3 tickets, then Anne has a 2/5 chance of winning. Does that make sense? If I buy 2, you buy 3, there's a 5 total tickets in the little pile. Have you ever done these raffles? Maybe I should pick one. So your chance of winning is 2/5. Does that make sense? Yeah. Okay, so the prize is worth $60. So if you have a 2/5 of chance of winning $60, your expected value is just 2/5 times 60. Does that make sense? Right, so like for example, if you had a half chance of winning $60, it's like worth $30 to you. Is that okay? So let's just do it here. Let's do A. Let's say raffle tickets are free. If they both have 0 tickets, what are their payoffs? 0, right? No one gets anything. If I give 0 tickets and Bob gets 1, what is my payoff? 0. And what is Bob's payoff? 60, right? Because Bob has the only ticket and will definitely win the prize. Okay? And how about, let's do this one. If I buy 1 and you buy 2, what's my payoff? 20, right? Because I have a 1/3 chance of winning, right? I have 1 out of the total 3 tickets, so 1/3 times 60 is 20. And what's your payoff? 40. Right? You have 2/3 chance of winning 60. So 2/3 times 60 is 40. Is that okay? Is everyone okay with this? Okay, so this is the A part. If the raffle tickets cost $6 each, how does it change? Does this change? No. How about this? Yes. This 0 doesn't change, but this 60 becomes 54, right? Does that make sense? Because you had to buy. And this, instead of 20, this should be 14, or 20 minus 6, because I have 20, but I bought a ticket for $6. This is 14. And this, instead of 40, this should be 28. 40 minus, so my gain is 40, but I have the cost of 2 times 6, which is 12. 40 minus 12 is 24. Are you okay? Yeah? Okay. All right, so the rest of it is just computation. Any questions? Okay. All right, so let me know if you have any questions. I have office hours today after class till 2. And Thursday I have office hours generally. So generally my office hours are Tuesdays and Thursdays 12:30 to 2. Okay. So let me know if you have questions. You can talk to your TAs too. Oh, somebody asked about the YouTube thing. So yeah, those you can see the some of these are the old video office hours, and I also put some of the screencasts up there. It seemed to work, so okay. I'll try to update that every week. Somebody asked also about having more time to do the homework. So I already put homework 2 up here. So it's still due a week from Thursday, so the due dates have not changed. But this way you'll have a little time, so you can look at it, and this way you have time to ask your TAs about it in section. This way you have a little more time to digest it before the TA section. Does that make sense? Okay. So this, if you look at the homework, if this is almost exactly the same as the first homework, except now I'm asking you to make the predictions. So we're going to talk about making predictions a little bit today and Thursday. Okay. We're going to talk about Nash equilibrium and iterative elimination of dominated strategies. So that's what this is about. Okay. Any other questions? Questions about the homework? Any other administrative things? Okay. Is it kind of hot in here a little bit? I wonder it's big. Okay. I'm tempted to mess with this thermostat a little bit. Can you hear me in the back too? Is it okay? I think we're the first class in this room on Tuesday, so that's why. Okay. All right. Okay, let's just get started. No more questions? Are we okay? Okay. All right. So, just to review, how do we write down a strategic form gain? Very complex. First step is players. Second is options. Third is chaos, right? And the last step is making a prediction of some sort. Okay, we're not sure yet about this. We haven't talked about this yet, so we will do it soon. All right, let's do. We're running a little bit behind because of that delay last week. So let's just do some examples, which I always love to do. This is a protest against regime. Okay, so this is the Berlin Wall. How do I model a protest? Huh? Yeah.
You know it's you and you stay home.
Yeah. So each person has a choice of whether to show up or not. So that's the choice. How many players do you want? How many people are think are involved in a protest? Thousands, a lot of people. Okay, we're going to simplify that down to how many people? Maybe one. We did one with one. But let's just not get that simple. What's the next most simple thing? 2. Okay, we'll make it 2 people. So each person can either show up or not. Okay? And this is, to me, is the essential aspect of a protest. So if everyone protests, it's a success. Okay. However, so if everyone protests, you want to join in, but protesting alone is dangerous. So if you're a protest organizer or a concert promoter, what's the main thing you want to try to do? You want to get the people excited about it and also get people to think that other people are excited about it, yes? That's kind of the key aspect of it, right? You're generating excitement. You want to make sure that each person knows that other people will be there. Okay. So this is a so-called coordination. So people want to come if other people are there, but no one wants to be the only person. Okay, so if a model that looks like this, you can either protest or stay home. I have 2 people. So let's throw in some payoffs here. Hey, what do you think we should do if both people protest? You here? What do you think? 10, this is pretty good, yeah? What if they both stay home? 0? Okay. What if I protest and you stay home?
Negative for you and 0 for me.
Yeah, this is like bad for me. This is where I get shot at or something. Okay? No, this is a real thing. I don't want to be the only person there, like hundreds of police out there. Okay, so minus 10 for me. We'll have a person 2. 0? Okay. You don't think person 2 feels guilty that his friend's getting shot at? Or? Okay, no. Person 2's just...
Might be friends.
Huh?
Might not be friends.
They might not be friends. That's true. Okay. How about if person 1 stays home and person 2 protests? So person 1 gets 0. And 2 gets what? Minus 10. Okay, is this a prisoner's dilemma? Okay, it's similar to one, right? Because the prisoner's dilemma, we had like a cooperative outcome. This is like where they both keep quiet. This is where they both confess, right? So this is similar, but is it a prisoner's dilemma? And the answer is no, right? Why not?
Because the other sections would have been the best. So
Yeah.
they would have been the best possible outcomes for an individual.
Exactly right. Yeah.
Oh, I was gonna say it's prisoner's dilemma is more of a zero-sum game in which your behavior inflicts something on the other person.
Yeah, well, I mean, the prisoner's dilemma is not a zero-sum game. In the sense that there is something which makes both people better off in prisoner's dilemma too. But in some sense, you're saying in a prisoner's dilemma you can kind of mess somebody up. That's what you're saying. But here, yeah, exactly.
Prisoner's dilemma, both parties are not communicating with each other.
Oh, that's interesting too. Yeah. Here you think they want to communicate with each other. Right? In a prisoner's dilemma, maybe there's, even if they could, there's no reason to do so. Yeah.
In prisoner's dilemma, your biggest gain is when you do that.
Yeah, exactly right. Yeah, that's kind of what you're saying. It's the same
That's
thing.
what I'm
Right? In the prisoner's dilemma, the best possible thing is if I kind of think, or I don't bring the present, you know, or I turn state's evidence and you don't. Whereas here, the best possible thing is if you both cooperate. Okay, makes sense. All right, so this is also a well-known game. It's called the coordination problem. Whoops. Okay, let's do rock, paper, scissors. Okay, this is oh my God, this is there's an international rock, paper, scissors tournament. Sometimes in bars will have rock, paper, scissors nights. Okay, how do you model this? Who are the players? 2. What are they? Rock, paper, scissors. Have you seen the one with Spock and the, you know what I'm talking about? Spock and then like something. You know what I'm talking about?
Yeah.
Okay, it's from Big Bang Theory. All right, here are the actions. Okay, rock. So let's see. What if you both do rock? 0. This is like a tie. What if you both do paper? 0s. What if you both do scissors? What if I do rock and you do paper? Then I lose, right? So it's like -1, and you get what? 1, right? Because you win. What if I do paper and you do rock? I kind of win, right? And when you get what? -1. If I do rock and you do scissors, then what? Rock wins, so it's 1 minus 1. If I do scissors and you do rock, -1, 1. Finally, if I do paper and you do scissors, then -1, 1. And this is going to be what? I do scissors, you do rock. So I do scissors, you do paper. 1 minus 1. Thanks. Okay. Is it okay? Okay. All right. How about Battleship? This is if you ever play Battleship, you know what this is? It's a game you play which doesn't involve computers. Those things used to exist, or still exist. I have a Battleship. I brought my Battleship today. Some people have never seen this before, right? No? Okay, if you want to, okay, anyway, we can pass it on right now. Thank you. Oh, sorry.
It's all good.
All right, so say we're playing on a small board. So the way the Battleship works is one person will look at the little ship on a board, the other person like fires missiles. So say the board only has 4 spaces, so we're going to totally simplify it. Okay. All right, so who are the players? 2. And so one person does what?
Calls out a coordinate.
Yeah, one person calls out the coordinate, like one person fires the missile, the other person does what?
Checks it.
Put the ships, right? Actually, you both do that in tournaments, but yeah. Okay, so that's Battleship. So this is my version of it. Okay, so person 1 can either fire a missile this space, that way, that one. Okay. Person 2, say it's like a ship which has 2 spaces. Okay, so you can either put it there, there, or there. Does that make sense? Okay. If you play Battleship a lot, what's one thing you learn to do quickly?
You space them so that you, if you don't get it, you don't call next to each other.
Yeah. Somebody else?
You lie.
Huh?
You lie excessively.
You lie. You say.
You like memorize moves.
Yeah.
You memorize which ones you already did, of course, and then like.
Yeah, exactly.
You figure out the type of game they're playing.
Okay.
And then swap ones.
So let's see, we'll talk about this. Let's do this as okay, so what happens here? If our person 1 puts a missile here and person 2 puts the ship there, then what happens? What's the payoff here?
That's a hit.
That's a hit. You sunk my battleship.
Well, not sunk yet.
Not sunk exactly, but does it make sense here? Person 1 wins, yes? And person 2 loses. How about here?
Losing would be a -1, wouldn't it? Why is that a 0?
You want to make it a -1?
Yeah, 0.
Fine.
No, we're 0.
It doesn't, it doesn't matter much. Okay, how about here? This is where 1 fires it, and then 2, it misses, right? So here, 2 wins here. I think 2 kind of wins, yeah?
When I played, you had to call out near misses.
Let him teach.
It's okay. The strict rules is that, there's no, you only have to call out the miss. Okay, so this is -1. 1 like that, I think. How about this one here? This is what? -1, 1, right? This is person 1 misses. Does it make sense? Okay. How about here? This is where 1 wins. Okay. All right. How about here? Who wins? 1 wins. Yes. Over here, 2 wins. Over here, who wins here?
2.
2, right? -1, 1. Okay. Over here, I think 1 wins, right? Now over here, this is where 1 wins. Okay. Here. This is where 2 wins. This is where what? 2 wins. And here what? 1 wins. Okay. Any questions? If you have any questions about or comments about other people in the class, talk to me, please. I don't want like a lot of catcalling and that kind of thing in the class. It kind of messes up the feel. So if you feel like things are going over too long or whatever, any other objections, please talk to me about it. But let's not have like a whole free-for-all going on in the class because I'd rather not do that. Okay. All right. Any questions? This is my battleship. Yeah.
Would this be a 0-sum game?
Is this a zero-sum game?
You get
Well, the easy way to check is just to see if these numbers add up to 0. Do they?
Yes.
Yeah, they do. So the term zero-sum game is actually something I don't really like that much because remember we said the order doesn't matter as long as the numbers change, because so whether it's zero-sum depends on the actual number. So there's a more technical way of thinking about it. Anyway, in this case, it is a zero-sum game. What I mean is that in any given case, this and this becomes zero. Okay. Any other questions? Okay. Oh, this is my plotting thing. Did you guys do the 3-person game in the homework? Yeah. Is it okay? Yeah. Okay. Yeah. It's a little confusing, but once you get used to it, it's okay. Now we know how to write down a strategic form game. First step, focus on the relevant individuals. Second step is options. Third step is chaos. Fourth step is prediction. We don't know yet how to do that. Now we're going to do how do we make a prediction in a strategic form game or table? Okay, let's look at the simple individual model. So if you want to answer a new question, just always go back to what you used to do and then try to imitate. Just try to why reinvent the wheel each time. So let's look at a simple model of individual choice and work from there. By the Blueberry case. So in our simplest model of individual choice, what do we do? What was the first part? Player, one person. Second part was options. Third part was chaos, right? And then how do we make a prediction? Choose the one with the highest payoff, right? Okay, so what's the analogous thing in a strategic form game? What does it mean in a strategic form game to choose the alternative with the highest payoff? Huh? That's a good question. Yeah, you could sum them. Okay, so should we going to do that? Let's think about that. Okay, so for example, let's go to our rock, paper, scissors. Is that going to work here? So if I choose rock, the sum of my pairs is going to be what? 0, -1, and 1. Yeah? If I do paper, it's 1, 0, and -1. So it's not going to work too well because they're all zeros, right? But it might, I don't know. But the deeper issue is in some sense this. If I'm summing up, it kind of means that I think that you're going to either play rock, paper, or scissors, and it's equally likely that that will happen. But is that going to be the case? Yeah, maybe, but not always, right? See what I'm saying? Okay, oh, go ahead. Is there a question right here? Okay, so let's see. For example, let's do another example. Oh, how about this? This is my battleship thing. Okay, if I'm summing up, this is 1, -1, and -1, whereas this is 1, 1, and -1. So under your summing up rule, I should probably pick this as opposed to this, right? Now, but kind of does that make sense? Well, it does, and it doesn't. I mean, it's not terrible, but the idea is that to sum it up means that I think you're going to play this, this, and this equally likely, right? But you might do things depending on your payoffs, right? Right. So in other words, in fact, you might want to avoid this, right? So in other words, my choice depends on what you're going to do, etc., etc., etc. Right. So it's not. I can't use such a simple rule. Does that make sense? Okay. So anyway, let's go. Any other questions? Any other thoughts about how we would do this?
Didn't we already talk about that? And that the person is going to do what they think will provide the highest payoff, regardless of what the other person does?
Yeah, we did talk about this. So that's where we're going to start. So the idea is that the idea of the summing thing is that it doesn't really always going to work because my payoff does depend on what somebody else does, right? But there are cases where that's not a big issue. So let me just talk about this. What does it mean in a strategic form game to choose the alternative for the highest payoff? Well, we just said in a strategic form game, outcomes have payoffs. So you can't really choose the best thing because you don't have control over the whole thing, right? In the prisoner's dilemma, I would love to be in a situation where I tell on you and you're quiet, right? But I can't control you, right? That's not necessarily, I would love to have the best thing, but that's not necessarily going to happen. You have limited control over it. Okay, but there is still something we can say. Okay. So for example, let's take the prisoner's dilemma. This is my Ryan Gosling thing. So, for Richard, can we unambiguously say that talking is better than not talking? Okay, so this is kind of what we've said. Okay, let's just break it down. If Justin talks, Richard's choosing between talking and not talking. If Justin talks and if Richard talks, Richard gets what? This is 0, yeah? If Richard were to not talk, Justin would get what? Sorry, Richard would get what? -10, yes? So given that Justin's talking, Richard's choosing between the 0 and the -10. Okay? Which is the bigger number? 0, right? So if Justin talks, what is Richard going to do? Talk.
If he knows that Justin's talking.
Right. What if Justin doesn't talk? Now Richard is choosing between what? The 10 and the 5. Which is the bigger number? 10. So if Justin doesn't talk, what does Richard want to do? Talk. Okay, so if Justin talks, what does Richard want to do? If Justin doesn't talk, what does Richard want to do? Talk. Right? So no matter what Justin does, Richard wants to talk. Yeah? Does that make sense? Okay. So the answer is yes. For Richard, the payoff from talking is greater than the payoff from not talking, no matter what Justin does. Okay? So in this prisoner's dilemma, Richard doesn't have full control over the payoff. However, regardless of what Justin does, Richard would be better off talking than not talking.
There's an assumption then that Richard doesn't love Justin more than himself.
Well, we have to take the payoffs as given. So if you think that the payoffs are different, then yeah. In the homework, in the last, did you do the last problem with return to forever thing? Yeah, there's an element of that, like how much do you care about your friend percentages? Anyway. Another way to say this is that Richard would be stupid to not talk. Okay? Talking is always better. So there's no possible way you could justify not talking. If Justin talks, Richard would be better off talking. If Justin doesn't talk, Richard would be better off talking. Okay, anyway, so this is the technical definition of what we're saying. We say that for a given person, strategy A strongly dominates, this is a definition. Strategy B, if the person's payoff from strategy A is greater than her payoff from strategy B, regardless of what everyone else does. So if strategy A strongly dominates strategy B, we predict that strategy B will never be great. So if your payoff from A is always greater than your payoff from B, then you should never play B, because A is always better. Does this make sense?
Sorry?
Yeah.
And for this definition of what?
Huh?
Is there like a term, this is the definition of?
Yeah, strong domination, strongly dominates. That's in the red.
Is this specifically for prisoners or not? Or
No, this is true for all games. Yeah.
Okay.
So this is our first kind of step toward this formula. Yeah.
Okay.
So in particular, in the prisoner's dilemmas, talking strongly dominates not talking. So both are true. Yeah. Talking strongly dominates not talking because your payoff from talking is greater than the payoff from not talking, regardless of what everyone else does. Okay. All right. So therefore, we'll predict that both will talk. And if you go back to our previous examples, we will predict that both will not bring a present, both will not use green technology, and both will use negative attack after. It's a prediction. Okay. And notice that both people could get a better outcome if they kept quiet, or if they both bought a present, if they both used green technology, or both were afraid from everything. Do you want me to throw out the prison's one again? So we just said that, what's a prediction in this game? What is Richard going to do? What is Justin going to do? In the end, they'll get what? The 0-0. Could they both be better off if they did something different? Yeah, they could both be better off if they don't talk either. Okay. Do you want to do the version with the presents? No. No? It's the same thing.
Can we go
Yeah.
to the definition slide for like a minute?
Sure. Yeah.
The only result in the first is they both choose better for themselves, so 0-0.
Right, they only have a 0-0. Even though they both change, they can both get better. Similarly with a present, right? Why should I bring a present for you? It just costs me, right? It just costs me $1. So I'm never going to bring a present. Therefore, we both end up at 0-0, even though both of us would have rather bought a present, we can get weak. Okay, are we okay? Okay. All right. So this is a second big question. The first one was about rationality. What does rationality mean? And this is our second kind of big question. It's a substantive question. Why does government exist? Okay, so we're soon going to have an election. Why do we do this? Yeah.
Protection of property and liberty.
Okay. Yeah, it's sort of a protection of property rights. Yeah. But let's before we ask this, what is government? What defines government? Let's talk about that. What is government?
Monopoly of force.
Huh?
Monopoly of force.
Monopoly of force. It's interesting. Any other thoughts? Yeah.
Bureaucracies that delegate resources.
Uh-huh. Bureaucracy, so lots of bureaucracy. Any other thoughts? Yeah.
There's this phrase like mutual coercion, mutually agreed upon. So
Uh-huh.
it's when you, well, I don't know, that might actually.
No, okay, no, I got you. So this is like a monopoly of force kind of thing, was it coercion kind of thing?
Yeah, well, you agreed to be under the power of another entity
No.
because it yields a better result for everyone.
Okay, yeah.
I was gonna say unity of command. Unity of command.
Oh, okay.
I think he's like talking about like the social contract.
Uh-huh.
Law.
Uh-huh.
Like a set of institutions.
Sure.
It's like people give up
Sure. Okay. There was another one on here too. Oh, keep going.
An institution for collective action.
Uh-huh. Okay. Yeah, yeah, okay. You guys are more cynical. Go ahead.
So wait, so either control or social.
Yeah. So a lot of times when I do this example, people say it's about voting, and I'll say, well, there are a lot of things which, like for example, organizations which vote, like just student government UCLA is voting, but it's not a government. Right? The American Medical Association, or has voting, but it's not a government. Okay. And the standard definition which people are, so actually there are lots of bureaucracies which are not governments too. Right? Okay. Like UCLA bureaucracy is bureaucracy, but it's not a government. And what makes governments different from other large organizations? Other organizations have command and control too, like you're saying, right? Like UCLA has command and control. Okay. The difference of the government is the very first answer, which is what?
Monopoly and force.
Monopoly and force. Like UCLA cannot put me in jail directly. There's no UCLA jail. Right? As far as I know, there's no UCLA jail. Right? They'll have to call the police, which then put me in the regular jail. You see what I'm saying? The AMA does not have an AMA jail. Yeah? Okay. Because only the government has that monopoly. The government claims a monopoly on the use of force. Okay? An essential asset of the government, even a democracy, is that it can successfully threaten its own citizens with violence and prison. Okay? So even democracies, which try to preserve liberty, still have an element which is coercive. Okay? Make sense? Okay, so even in democracies, for example, people who do not pay taxes are imprisoned. Okay, so why is this? Why is it, even in a gay state which supposedly gives us all liberty and freedoms and all this, why do we still have, or why do we have governments which are violent? So one answer is that a government might exist to purely predate on citizens. So there are governments out there which are like this. They're like dictatorships, or there's plenty of governments even now which mainly just exist to kind of tax people and predate on them. Okay. But many governments are liked by citizens, so these governments must offer some benefits. In other words, not all governments are hated. A lot of governments are liked, but they still have to have this coercive aspect. Okay? Why is that? In other words, why does a government we all love still have to have prisons? Why can't we just do taxes voluntarily because we all support it?
Because everybody wants others to pay for taxes, but they themselves do not want to pay for it.
Yeah, exactly. Yeah.
I was thinking it's in the whole nature, the structure of this class, it's because people are self-interested, and my interests are always the same as yours.
Yeah, exactly. Okay. So exactly, it's exactly this thing. So this is the standard answer. Okay, so if everyone gets benefits, why is force necessary? The answer is this game, the prisoner's dilemma. Okay, in the prisoner's dilemma, this is the version with the presents. So you can either pay taxes or not. If we both don't pay taxes, then we don't have any roads, schools, just all sit around, making patterns of dirt and stuff. There's no public services, no electricity, no water. So we all want to pay taxes and we get better off. However, the best thing is for me is to do what? For everyone else to pay taxes, but me not to. Yeah? Okay? That's the best thing for me. Yeah? Okay, so it's the best for me. It's just like not bringing a present to the party. Okay? It's better for me to not bring a present and have the other person bring it.
But that's for society as a whole.
Yeah, exactly. But for society as a whole, if we said everyone this week we all get better off, we all pay taxes. However, my individual motivations do not, therefore we get better off. Okay, so this is the standard explanation of why government exists.
So could we justify the existence of government to buy that assertion?
Oh yeah. Okay, so if I put government in here, how would the government? Okay, so how would this game change if I put government in here? Yeah.
Adds cost to not pay.
Yeah. Is there somebody over here? There's another. Over here? I saw 3 hands go up. Yeah.
Yeah, government just reduces the free payoff.
Yeah, exactly right. What government does is it makes this a lot worse. Right? If you don't pay, this 0 becomes like what? Negative 10 or something like that. Right? Okay, so everyone agrees that taxes are socially good, but everyone wants a free ride. Have you heard the so-called free rider problem? Yeah. That's what it is. Okay, so let's. Government exists to solve prisoners' number problems by threatening punishment. That's the whole point. That's a standard answer for why government exists. It threatens punishment in order to solve these collective actions, these prisoners going. Okay, so this is my incarceration. This is what I said. So say that you take away -10 if you don't pay your taxes. Okay, so this 0 becomes a -10, right? And this 4 becomes what? Minus 6, right? I'm just taking away 10. So I'm just penalizing 10 if you don't pay. So this becomes a -10, that becomes -6. Yeah, that's all it changes. Yeah?
Isn't the result of you not paying those? Isn't the result of you not paying those still you going to prison? So shouldn't it still be -10? Because this resulting in the same thing.
Oh, if you this should be -10 too?
Yeah, this is the -6.
Oh, I guess the idea is you can pay -10 plus but you don't pay your taxes. So, well, you go to prison and you have to pay your taxes still.
Okay.
That's fine. You
That
can do
doesn't
that
happen
way.
in every case though, some people get away with it.
I'm okay with it. So say that we'll do that. Okay. All right. Any other questions about that? So that's a fast answer. Government exists to put that -10 on there. So therefore, let's do some denomination. In this game, what would you do? Would you pay or not pay? Okay, because if the other person doesn't pay, which is better, -1 or -10? -1, so you're going to pay. If the other person pays their taxes, what are you going to do? 3 or -10? 3. So no matter what happens, you're better off what? Yeah. So maybe. Let's do another example. This is kind of an abstract example. So here, person 1 can either play A or B. Person 2 does either A or B. Do you see anything which is dominated? Okay, let's check for person 1. Does A dominate B for person 1? Okay, so remember the definition. A strongly dominates B if the payoff from A is better than the payoff from B, regardless of what everyone else does. If person 2 plays A, is playing A for person 1 better than playing B? Yes. 4 is better than 0. However, person 2 does B, is A still better than 0? Sorry, A better than B? No, right? 0 is worse than 2. Make sense? Okay, so if 2 does A, yes, for 1, A is better than B. But if 2 does B, A is worse than B. Yeah? So for person 1, does A strongly dominate B? No, right? If A is strongly dominate B, it must be that the payoff from A is better than the payoff from B, regardless of what 2 does. Does this make sense?
Yeah.
Okay. How about let's check person 2. Does person 2, does A strongly dominate B?
No.
Well, 3 is worse than 6, no, right? How does B strongly dominate A?
Yes.
Yes. Okay, let's check. If person 1 does A, if person 2 does B, 6 is better than 3. Yes?
So B is
And if person 1 does B, person 2 is playing B better than A?
yes.
Yes.
Right. So in other words, no matter what 1 does, for person 2, B is better than A. Yes?
Yes.
6 is better than 3, and -1 is better than 1. Yeah? Okay, so for person 2, what can we say? Playing B strongly dominates playing A. Okay? So for person 1, we do not have strong domination. Strategy 1A is not always better than 1B. But for person 2, strategy 2B does strongly dominate 2A. 6 is better than 3, -1 is better than this. So the prediction is person 2 will never play A. There's no possible justification for person 2 playing B. Person 2 playing B is always better than playing A, so 2 should never play it. How about this example? Can you see it? This is kind of like an inspection thing. Can anybody see it? How about 1A versus B? Does 1A strongly dominate 1B?
2C's always been 4 too, right? No.
Okay, let's just. Okay, 8 is better than 4, but 0 is less than 3, right? So it's not like A is always better than B for 1. Okay? Can anybody see it? I think somebody said it already. See any domination? C and B for person 2? Well, check C and B for person 1. Does B dominate C for person 1? 7 is better than 6. But 3 is worse than 5, right? So it's not like B is always better than C, right? Is C better than B for person 1? Oh no, 1 is less than 4. Yeah? However, I think somebody said it, for person 2, what? C is better than B. Okay? Remember the definition? 2C strongly dominates 2B if, no matter what 1 does, the pair from C is better than the pair from B. So 3 is better than 0, 5 is better than 4, 8 is better than 2. Make sense? Okay, so therefore the conclusion is what? Will 2 ever play B? No, 2 will never play B because no matter what 1 does, for 2 playing C is better. Yeah? Make sense? Right. 2C strongly dominates 2B. Any questions about that? Alright, so prediction 2B will never be played. Let's do a little movie clip. Everyone okay? So we're starting to learn about how to predict. Let's do our movie clip thing. Okay. Okay.
Fred! There's no time. Do you still want to dance with me?
I broke his Justin Green!
Do you hear that? That's the future of dance sport, and no one's gonna change it. Please applaud.
Listen to the rhythm.
Has anybody seen this movie? It's a great movie. Have you seen Great Gatsby?
Yes.
That's by Baz Luhrmann. This is Baz Luhrmann's first movie. Have you seen The Get Down on Netflix?
Yeah.
That's also Baz Luhrmann. Okay. His movies are all sort of the same. They're all about this kind of stuff. All right, so, oops. It's a great movie. All right, so what's going on there? What's the interesting part about that? If I were getting through, what's the interesting part about that movie? Yeah, so yeah, who are the people?
The crowd and then the other guy on stage.
Yeah. So sometimes people say it's about the decision to dance. But I think that the interesting thing is more the clapping, yeah? That's kind of, because it really starts from nothing. Oh, there's a backstory too, which is, so they're in a ballroom dance competition. There are only certain moves are allowed, but Scott Hastings and a friend, that's a couple, so we've got to do some real different dance moves, which are not strictly ballroom dance. So that's why they disqualified doing these extra special moves. Anyway, okay, so I think the interesting question is why they choose to dance, because it goes like from 0 to nothing, right? No one claps, no one knows what to do, but then in the end everyone claps. So how do I model that? Who are the players? Yeah, parents. Well, literally everybody in the audience makes a decision, but we're going to simplify it down to just 2 people. Okay, which I think is what?
Person one and audience.
Yeah, person one and audience. Yeah.
Why was thinking supporting and not supporting people who are on the other side of the coin on whether or not they should be disqualified?
Yeah, okay. Okay, so I think, well, here everyone ends up big clapping, right? So it's not like, I don't think that anybody was against the couple. But it's true that some people are different, right? So some people didn't clap in the beginning. Literally only one person clapped in the beginning, right? So that's important. We need that person. That person's Doug. That's Scott's father, by the way. He's like my role model as a father. Like if my daughter scores an own goal in soccer, I'm saying, "Man, go for it, all right." I'm just clapping. So I'm going to put Doug as one, and then this is Fran's parents, Rico and Yaya. I'll make them one parent. So I'll simplify the mass, I'll make it just 2 people. Okay, so let's think about it. So what are their actions? Like I said, if they're clap or not. So let's just put in the payouts. So let's do this. What should I put? What's the best thing for Doug? Claps, right? Everyone clapping, right? So I want to put this to 10. How about for Rico and Yaya? Do they like that?
Yeah.
Yeah, sure. Okay, what if, let's see, what's the worst thing for Doug?
No.
Okay, is it this?
Yes.
Or I'm thinking it's, I don't know.
Oh, he claps and nobody else does?
I think this is actually, okay, hold on. Let me make sure. I think this is worse, right? Because this is where Rico, he would actually be embarrassed if he doesn't clap and Rico and Yaya clap, maybe? No? He starts clapping? Wait, well, let's, go ahead.
Well, Doug starts like the beginning of the clapping and the parents join in.
Right. So, but let's just say, what if Doug, so you're saying that this is not even an issue, right? Doug's just going to clap already? But, okay, I need to sign something here. This is where Doug doesn't clap and Rico and Yaya clap. What do you think? Is this good for Doug? No, right? Is it the worst thing? Yeah.
But Rico and Yaya only clap if Doug starts.
Yeah, that's a difference, right? Okay, but we'll put this in the game. I want to make this a minus 5. To me, that's the worst thing for Doug. Yeah? Okay. Do you want to make it a 0? I'm okay with that. I just want to, what do you want to do? Minus 5's okay?
Yeah.
How about here? What do you think about this? 0, maybe? Oop. Okay, how about now for this? This is where Doug claps and Rico and Yaya don't.
That's not good for him either.
It's not as, what?
5.
I think this is 5, right? It's better than 0 or minus 5.
Yeah.
Yeah? It's not the best thing, but still, he's willing to clap by himself, right? I think this is 5. Now let's do Rico and Yaya. Okay. I want to say, if Doug claps and Rico and Yaya doesn't, what's going on here? Minus 5? No, hold on. Rico and Yaya are a little different, right? What's the, okay, let's see. I want to say, is this right? Okay, what if they both don't clap? Want to make that a 0? 0. And then what about this? This is where Doug doesn't and Rico and Yaya clap. This, I think, is negative 5, right? Because they would not be willing to clap by themselves. They're different from Doug that way, right? They're just a little more embarrassed, yes? Okay. And I think this is going to be what? This is where Doug claps and they don't?
That's so negative.
No, hold on. This is where Doug claps and they don't. I think this is what? 2? I think it's pretty good, right? It's better than 0, yeah? I think, right? I think this is okay, no? For obviously the best for both if they both clap. Say this is 0s. Okay. And this is if Doug doesn't clap and Rico and Yaya claps, Doug is embarrassed. Rico and Yaya are embarrassed if they clap. If Doug is the only one who claps, they both kind of like that, but it's not as good as if they. Yeah.
In terms of the embarrassment for Rico clapping and Doug not clapping, for the sake of finding out a stronger bonding strategy, why would they be, like, your prediction is they get embarrassed, but either way they're showing support for the person you care for. So it doesn't matter if the person is support versus they're clapping ultra, not for their.
Okay. So you're saying about Rico and Yaya, yes? So you're saying that this should not be negative 5?
I mean,
okay.
I can see why Doug would be negative. I would even think Doug wouldn't be negative because the person he cares for is getting support that way.
We can change it. Let's change it. We can. So what are you saying? This should be what then for Doug? 5? Can I make it 5? Maybe just Doug wants somebody to clap. That's okay with me. What do you want to make this?
That's what I was hoping for.
So this, okay, that's fine. Let's do that. And how about for Rico and Yaya? Okay, now this is, should I make this a 5? I don't think, no, this part I'm not willing to disagree with, right? Because Rico and Yaya didn't clap by themselves, right? They are a little more embarrassed. It's a little bit different. Doug is totally, that's what's so great about Doug. Doug's willing to just do it by himself. Yeah? Rico and Yaya are a little bit more conservative. Right? They want somebody else at least. They don't want to be the very first. Okay? So I'm going to make that a minus 5. And they would be a little embarrassed. Are we good?
Yeah.
Okay. Okay. So let's see. Okay, do I have any strong domination? What? Yeah. But Doug clapping is always better than not. That's what's so great about Doug. It doesn't matter what everyone else does. He doesn't mind being the only person in the world who claps. As you see, that's what's so great about Doug. That's what makes him a great dad. He doesn't care. He's just clapping. He doesn't care at all about other people. No matter what everyone else does, you can put millions of other people in the game, he's always going to want to clap. For him, clapping is always better than not clapping. Strong domination. 10 is better than 5, 5 is better than 0. Okay, does that make sense? How about Rico and Yaya? For Rico and Yaya, does clapping strongly dominate not clapping? No, now it's slightly different, right? If Doug claps, do Rico and Yaya want to clap? Yes. 10 is better than 5. However, if Doug doesn't clap, do Rico and Yaya want to clap? No. Okay. They're a little more hesitant. They don't want to be the only person. Make sense? So, yes, for Doug, clapping strongly dominates not clapping. Okay? So we will predict that Doug will clap. Okay? Yeah.
Does that mean we can't predict anything for Rico and Yaya?
That's a good question. That's what we predict. All right.
Given
So-
that Doug's gonna clap, we can predict that.
Yeah, exactly. That's what I said. So, okay. So first we're going to say that for Doug, clapping strongly dominates on clapping. Therefore, Doug is never going to play this strategy. Okay? All right. But then, given that, we can say something about Rico and Yaya.
So on the exam, due to arbitrariness and assigning payoffs, would it be in our best interest to write our rationale as to why we think that is?
In an exam, there will never be this much slippage, just because it will take us a long time to grade this. So if you look at the old exam, it's all pretty tough. But but this is also what makes it kind of interesting to think about exactly this kind of stuff. Okay. All right. So to make a prediction of a strategic form game, you can see at the very least that a strategy which is strongly dominated will never be played. So in other words, Doug will never play not clap. Doug will always clap. Now, can we say more? Okay, this is the question which was asked. Okay, now I want to make sure I don't get confused, so I will do this. Take the old game, put it out. Okay, all right. Okay, so. What's the matter here? Let's just do it this way. Okay, so this is the game I had. For Doug, clapping strongly dominates not clapping. So this is the idea. We can then eliminate this part. And this is actually, people said this at the beginning, right? Why do we even have to put this here? Because Doug's clapping, right? So Doug is always going to clap, so we can eliminate this. Doug will never play this strategy. Yes? Make sense? Okay, so therefore, so therefore, I want to make sure I'm confused here. Okay, is this the version I had? Yes, right? Oh yeah, so I got rid of that. See, I eliminated it. See what I did? Okay. Because this is where Doug not clapping used to be. I erased it. Because Doug's never going to not clap. Yes? Yeah. Therefore, we have this game. In this game, what can we say about Rico and Yaya? They'll definitely clap. Why? Because 10 is better than 5. In this small game, can we say anything about strong domination? Does Rico and Yaya, is clapping strongly dominate not? Yeah, because no matter what Doug does, in this case it's just one thing, 10 is better than 5. Does that make sense? So we kind of made a two-step argument. The first step is that Doug would always clap. Given that Doug will always clap, Rico and Yaya will therefore not clap. Okay? And that's what we have, that's what we saw. Now in the smaller game for Rico and Yaya, clapping strongly dominates not. So therefore we can eliminate that. And this is what we have left. What's the prediction? Both will clap, yes. Doug will surely clap, and given that, Rico and Yaya. So we are left with this game. The prediction is that both Doug and Rico and Yaya fell. Makes sense? So it's kind of like a two-step thing. First step was we'll say that Doug will always clap, given that Rico and Yaya will clap. Okay, so we know how to write down a strategic form game. Stuff. Okay, the prediction. Use strong domination. What the punchline is, we can iteratively eliminate strongly dominated strategies. So not only can we eliminate strongly dominated strategies, but once we eliminate one, we can then eliminate more stuff. Okay, iteratively means doing over and over again. So we'll show how to do this. So we first eliminate some strategies. etc., and then see if we can eliminate more in an iterative process. This method is called the iterative elimination of strongly dominated strategies. Okay, so you cross out strongly dominated strategies, and then see if you can cross out more, and try to keep on doing that until you stop. Okay, so this is an example we did before. Oh, do you need that? Do you need this slide?
Yeah.
My last time, somebody just had an iPad, just take a picture of it and then kind of notate it. So this is the iterative elimination of strongly dominated strategies. So when you think about this, think of the Doug and Rico and Yaya example. Doug will always clap, therefore Rico and Yaya will always. Okay, can I go?
Yeah.
Is it okay? All right, so let's do this example. So we said this before. Do you see what is eliminated? What is dominated? 2b is dominated by 2c, right? Because 3 is better than 0, 5 is better than 4, 8 is better than 2. Yeah? Okay. So 2c strongly dominates 2b. Therefore, we're going to get rid of that 2b. It's as if 2 will never play b because it's just done. Because c is always better. So therefore, 2 is never going to play b. Right? So it's as if that's not part of the game. It's just crazy for a person to do that. 2 is never going to play b. Now, what can we say for 1? I think what? 1b dominates 1c, yeah? In this smaller game, right? Because 4 is better than 1 and 7 is better than 6. Yeah? So in other words, given that 2 is never going to play b, now 1 is never going to play b. There's no case in which c is better than b. B is always better than c. Yeah? Makes sense? So in this case, 1 will always, b is always better than c, so therefore 1 will never play c, right? Okay, so in this smaller game, 1b strongly dominates 1c. So erase that. Now what? In this game. 2c strongly dominates 2a. Yeah? 3 is better than 1, 5 is better than 0. Yeah? In this game, 2 will always play c over 2 will never play d. Yeah? So therefore I'm going to eliminate this part. 2c strongly dominates 2a. I get rid of that. And finally, what can I say? 1 will choose, what would you choose? B, right? 7 is better than 2. So this small game, B strongly dominates A for 1. Okay, so that's it. Yeah.
Isn't 1c better than 2c?
1c. Sorry?
Isn't like the 1c, 2c option better for 2c, so they all want to pick that one?
So you're talking about this guy here?
Yeah.
This is better than.
Well, for 2c it's better than the one with the option above it.
For 2?
Yeah.
Yeah. Okay, let's go back to the original game. For 2, person 2 would rather have this 8 than this 5.
Yeah.
Right? But can 2 choose between the 8 and the 5? So can person 2 would love to get the 8, but can person 2 make the 8 happen? No, right, because the 8 versus 5 is up to 1. See? Person 2 is choosing C, so 2 gets either 3, 5, or 8. Whether 2 gets 3, 5, or 8 depends on what 1 does. Yeah, 2 says? Yeah. So again, the first step, 8 is better than 2, 5 is better than 4, 3 is better than 0, I eliminate B. Okay? Now, for person 1, B is better than C, right? 7 is better than 6, 4 is better than 1. Okay. 2 would love to get this, but 1's never going to play C. Yeah? So therefore we eliminate C. So now we have 3 is better than 1, 5 is better than 0, we move this, 7 better than 2. Now, going back, by the way, the most common confusion is exactly this kind of thing, which is, it's easy to say for person 2, I'm comparing, it's easy to forget whose numbers you're comparing with. So, for example, does 2c dominate 2a because 7 is better than 4 and 6 is better than 1?
No, because
No, right? Because the red numbers are 1s. Yeah? So you just have to remember, this will get used to that. For person 2, you're comparing the second numbers always. Yeah? You're comparing that 5 with the 0 and the 8 with the 9. Yeah? All right. Any questions about that? So this is area of eliminations of dominating strategy. So we'll do this on the home game for not for Thursday, but the weekend. So we have started this original game, and the end prediction is what? I think we ended up with what? With 7-5. Okay, the prediction. So this it's pretty good, right? We started with this complicated game, and then we were able to kind of just logic through it. The first thing was that 2 would never play B. Given that, person 1 will never play C, right? Given that, 2 will never play A. Given that, 1 will never play A. Okay. So that's a prediction. 1 will play B and 2 will play C. Or is it that? Any questions about that? Okay. All right. Let's do our fashion example. Are you okay with this? This is a little complicated. I mean, we're getting, but the key is just to try out lots of different examples. Let's do our Prada and Gucci thing. This is an example of a 3-person case. Is there something which is dominated? Remember, the definition of domination is A dominates B if my payoff from A is always greater than my payoff from B, regardless of what everyone else does.
And we'll choose Prada.
Okay, Anne will choose Prada because yeah, she just likes Prada. Like Anne likes Prada over Gucci always. So let's do the definition. Is the case that Anne choosing Prada gives a higher payoff than choosing Gucci, regardless of what everyone else does? Yes. Okay, if Bob chooses Gucci and Cindy does Gucci, Anne likes the 1 better than the 0, right? If Bob does Prada and Cindy goes Gucci, Anne likes the 1 better than the 0. Right? If Anne does Prada, Bob does Gucci and Cindy does Prada, Anne likes the 1 better than 0. If Bob does Prada, Cindy does Prada, Anne likes 1 better than 0. So yes, for Anne, Prada strongly dominates Gucci. Right? She always likes Prada over Gucci. She's never going to play Gucci. Right? Okay. So I'm going to eliminate that. Now, what can I eliminate? Is there anything I can eliminate now? Bob will always do Prada. Okay, let's check. Okay, again, the definition of strong domination is a strategy dominates another strongly if the payoff from this is greater than the payoff from this, regardless of what everyone else does. Okay, so for Bob choosing Prada, if Anne chooses Prada, Cindy does Gucci. If Bob chooses Prada, you'll get a 1. If he chooses Gucci, you'll get what? 0. So 1's better than 0. If Cindy were to choose Prada instead, and Anne's choosing Prada, Bob choosing Prada is getting 1. If he chooses Gucci, he'll get what? 0, right? So therefore, does Bob always get a better payoff from playing Prada over Gucci? Yes. So therefore, I'm going to eliminate Bob's Gucci strategy. Okay? Good. Finally, now what's going to happen?
Cindy's always going to do.
Cindy's just going to always, Cindy just simply chooses between that 1 and the -2. Again, the main source of confusion is just whose numbers are suited. So that's why colors are nice. Yeah? Cindy's green. Cindy's choosing that 1 versus the -2. She likes 1 better than -2. So therefore, she's going to choose Gucci. Yeah? Does that make sense? Yeah.
Before you eliminated Bob Gucci, could you have eliminated Prada?
Oh, that's a good question. Okay, let's go back. Let's go. So the first step we did was we eliminated Anne Gucci, right? But could we have done it another way? Is what you said, right? Okay, so can I eliminate Cindy's Prada? So let's see. For Cindy Gucci to strongly dominate Cindy Prada, the payoff for Gucci must be higher than the payoff for Prada, regardless of what everyone else does. Yeah?
Well, I'm just saying, like, after we already eliminated Anne Gucci.
Oh, I mean, at this point.
Yeah.
Okay, well, let me do this first. Yeah.
Can you, you don't even need to do the game if you know that Anne likes Prada, Bob wants Prada too, and then Cindy doesn't want to be like everyone else. You don't even need to do it.
Yeah, that's true. Exactly. So, in some sense, I'm just doing a much more complicated version of a simpler thing. But that's okay, because it's illustrating how you can do this in general. Yeah. You're right, it makes sense. Obviously, Anne will choose Prada, Bob will choose eliminate, and then Cindy will do that. Okay, well, let's just go back. Okay, listen to the very first case. Could I choose, does Gucci dominate Prada for Cindy? No, right? Because -2 is worse than 1, right? In this game, it's not like Cindy choosing Gucci is always better than Cindy choosing Prada. Yes?
But if you're just trying to find like the last one.
Yeah, yeah. Okay. Now, let's go back to this question. In this, if I call 911, I trust you. Okay, does Cindy playing Gucci dominate Cindy doing Prada? Let's check here. Well, this is interesting.
Yeah.
It kind of does. There's a tie here, right? -1 versus -1, right? And 1's better than -2, right? So yes, in some sense, we'll talk about in a second. Cindy doing Gucci is always at least as good as Cindy doing Prada. Yeah. So there's actually a name for that called read domination.
But the prompt tells us that Cindy's decision is subjective to how the first two players operate, right?
No, I mean there's no. The idea is here that they choose independently. It's not like the one goes first. But anyway, this is a cool thing. So yeah, I guess in theory we could have gone here and eliminated Cindy Prada too. All right. Does that make sense? Okay, I think we have about 5 minutes. Oh, 2 minutes. Okay, let's just do. Iterative elimination of strongly dominated strategies is a nice way to make a prediction in a game. But can we say more? So let me just do one little example. We say that for a given person, strategy A strongly dominates strategy B if the person's payoff from strategy A is greater than their payoff from strategy B, regardless of what everyone else does. What we're going to do is talk about this, and I'll just maybe we'll do this at the beginning of next class. We can say that for a given person, strategy A, so-called weakly dominates. So don't get obsessed with it. I'll give you an example in a second. If the person's payoff from strategy A is at least her payoff from strategy B, regardless of what everyone else does, it's sometimes greater. So this is exactly kind of what we did with the big question. Okay? All right, so let me just do an example. We have time. Why not? We have a minute. Okay, well, I'll just throw this out here. Remember the Princess Spy thing? What were the actual strategies? What were the strategies? Poison your cup, right? Or poison Vizzini's cup, right? But actually, that was the version we did, right? It was like Magic Penny. But actually, it wasn't like that. What did Wesley actually do? He poisoned both cups, right? So we actually have this kind of game. Yeah. Okay, so do we have time to put this together?
He didn't even consider the possibility, right? He assumed there was only 2 options. Not Vizzini.
Right, Vizzini, exactly. Okay. Oh, it's 12:15. All right. Okay, we'll see you next time. The homework's due on Thursday. The new homework is out there if you want to look at it over there.
Right after that stuff, then this wouldn't make sense because they're both storytellers.
I think there was a thing about the DVD, the window, was still in the theater, right? So I guess there was something about when you release the DVD, right? Because you want to keep the window large.
No, the homework to do is
because you want people to go see it. But I think there's an example of Higgs versus Bugs Life, right? So, anyway, that's answer. Okay, so they don't say I'm doing Higgs and Bugs Life, okay? I want to release the DVD as well, because I want people to come see the theaters, right? But at the same time, I don't want to release my DVD after the editing is done. Because then everyone will buy Bugs Life here and see it. Yeah. So therefore, I kind of want to release my DVD slightly earlier.
So that's why it doesn't work, because if you release it later, your competitors get to
Yeah, that's the idea.
Okay, thank you.
So our trip country, do we have attendance today?
No, that's not it. Ideally better, because
Send it in without sending out and discussion? No. Because everyone did I did put my full name, but I got the
Thank you. Is that for this Thursday?
Thursday night.
We haven't had the sign.
Yeah, the new one, people wanted to see it earlier, so I put it on. It's due this.
You said that like at one dominate like one had like priority over two. This one was taking the
Yeah.
That's right.
So I think I already get why this one was that.
Okay, so just step by step. So the first thing is to realize that two will never quite be is use very zeros and definitely cross that out. So like this. So now for person one I think he said you'll never play C, right? Because wars don't be on the side of the S.
Two wouldn't play this one. You know what I mean? So two would never play this one.
Yeah, it's true. But person two can't control the 5 versus 8. Yeah, because person one's choosing the low. Two can control the 5 versus the 0. But you've seen the causes.
So if two was here, if they were inverted, then that one would be played. Okay. So what about in a three-person card again? Which one has like the city have like
well, I mean, again, so there's no priority. It just so happens that it's easiest to check the and so clearly like so part of it is one thing so it's easy to just go it ends up in that's the easiest. But like you said, someone said before, you might be able to do
does it matter who goes first? Like,
Oh yeah, seriously. It's like, should I be?
wouldn't they not clap?
there's no order necessarily. If Rico and Yaya come out first, we couldn't make a distinction.
I get it. It's like,
Because Rico and Yaya came out. For Rico and Yaya,
it's like you need them free.
well, I
studied for 3 years.
so it's not like we have so the only thing to see is clearly so then once we say that we're not going the idea is something like you want to release your DVD. You want to keep your repeaters as well. Like, so you want to release the DVD. But if the competitor releases the competitor just for years, then they're going to make more money than you because people are going to buy your advances to the parts line. So therefore, they want to. We all gain the people that really want
Got it. So like the answers can be like drawn out.
Well, no, you can sort of say it's just like the numbers game. We both gainedly have a large choose a large game. We can think about the months that were the window before the because we both have released them to the 5 years after the season. We both gained. But I'd be a little more if I did 4 and 5. Because then I'll get all that. I know about writing. But then you're going to do 3 and then we'll do 2. Then we'll release the DVD.
You will see
No, I think I remember on the question. Yeah, that person wants to choose. That person would rather die in the middle.
So 0 would be better. Yeah, at least one person.
Let me check this thing.
I think it's fine if we just go here.
Yeah, do you want to just go my office or do you need to go? Or we can just do it out here.
Yeah, that's fine.